Hey everyone, we are back with another video making Damon Claw with Construct 3, and with me as always is Corey. Say hi, Corey.
Hey, how's it going?
And what I've been working on lately, eventing-wise, in this project is this sound setting option screen, which allows the player to separately set the overall master volume for the game, and then the sound effects volume levels and the background music volume levels all separately. And as you can see, they can also mute any of these volumes independently of each other. And you'll see soon, if I do mute any particular volume level, it keeps, or it remembers, I should say, where you had set the actual volume level. So when you unmute it, it's back to where you set it. It doesn't do anything stupid like reset it back to 0 in order to mute it or anything like that. The one thing I have not done yet with this system, it works great so long as you don't reset the game or close it, reopen it, because it won't remember your settings yet. It doesn't actually store it locally. But the reason I haven't done that part yet is there's this fourth tab here is actually going to be where you can store your settings. And the cool thing is you're actually going to be able to store all your settings in different slots, and that's going to be really handy, especially on mobile devices where maybe several family members will want to play Damon Claw and might want different sound settings, might want different control input settings and things like that. And as you remember with this game too, there's different ways you could set up the border around the screen. It could just be a pure black border or something that looks like a retro Amiga, that kind of stuff. So all of those settings will be saved into specific slots. So if different people are playing, they can always load in their particular slot before they start, and everything will be set up just how they like it. So before we go right into the events, let's just quickly review what's in the layout. There's quite a few layers here. Some of them are purely aesthetic, like this background here. And then you can't even see what's going on with these unless I hide it in the right order. But basically, each of these tabs, in order to organize it more easily, I just put the different things for those particular tabs on their own layers. But what's confusing is this thing here. It's just on the one layer, but it's got a different animation for each tab. But aside from that, the actual buttons that are needed and navigation buttons and stuff like that, they're going to be on the proper corresponding layers. So, for example, these sliders, and let's see, there we go. So you can see the actual things you touch for the slider bar to work, the actual little knobs, the fonts for that, that's all on the sound layer. And you can't see them because they're in the same spot, but there's also these actual mute buttons so that they can be touched. So that's all on the sound layer. And then other than that, one of the tricky things is there's these buttons. There's done button, reset button, and there's some hidden ones here that actually have no graphics in them. And that was necessary for the navigation system to work in the easiest way possible. They're in the same family as those other buttons. They just don't have any graphics. And there's one hidden here for each spot. And that's basically, you'll see in the code, that's how it knows where to put this pointer.
Right.
So it'll go there, there, or there when you have either of those things selected. So I think that's about all we need to know as far as what is in the layout. So before we go into the actual event sheet for settings, there's just one thing I had to add at the loading screen, the very beginning of the game, and that is I actually copied and pasted the events that loaded the dictionary data from, I used the AJAX object to request stored data text. So I'm actually loading a text file and waiting to retrieve that data. And that text file is a file called stored data that I made and added here. And I used the dictionary file maker, the same one we use to make the dialogue, but in this case I just put master volume as a dictionary key and then the value, like a default value, which would, it's all arbitrary right now, like what the default values are. We'll figure that out before we publish the game. But it was just a matter of starting somewhere. It needed a default settings file to load. And then when you change the settings, and then eventually once you save them, it'll save onto that text file as well, which will be installed the root folder of wherever the user installs the game. So we're requesting to get this data from the file. And then this basically says once that's complete, because you could see we added a tag to this request for data called save data. And then it says on save data completed, then load into the save dictionary. So I created a save dictionary file, which is just a regular dictionary object in Construct, and I just renamed it to save dictionary. And I say load from JSON string, and then I get that data that it just got from that text file. So we're dumping in the dictionary file data from the file we made with the dictionary file maker. I'm picturing Monk making a return in this video. Instead of triptych, it'll be dictionary file. All right. But anyway, and then what we're doing is, so we trigger once it's not empty. I'll just say it's from now on, so it's not a problem. All right, so we're setting some global values to the values that were stored in that text file that's now in the dictionary. So there's master volume, sound volume, and music volume. And then we're doing the same thing with the actual master volume, which is actually something you can set in Construct. And then you can also set volume levels for specific tags. And every time you play, you'll see here, or actually not here, in another layout you'll see shortly, if you play an audio file, you can give it a tag. And then you can do things to all audio that's playing that happens to have that tag, like stop any sound with that tag from playing, or mute it, or change its volume, or do other special effects to the sound. So that's why we have, whenever we start a music file playing in the game engine, we set that tag for that file to music. Same thing with sound effects, with sounds. So that's what we're doing here. And then, at the beginning, I set time scale to 0. And the reason I did this is because the code that was here before is what makes the game fade in, and the little sound effect of the cartridge being put into a game console, and then that little sound after that when our logo appears. Mm-hmm. And all of that was based on time, like time is greater than 4 seconds, that kind of stuff.
Right, yeah.
And I don't want the game to start fading in while it's still trying to load that dictionary file. It should finish that first and make sure it's got the data, because if it starts playing sound effects before it finishes loading the dictionary file, even if you had set your game to be muted, it would play these sounds, which would be really annoying if you're playing this game on your cell phone late at night and you accidentally wake up your family or whatever.
Right.
You know what I mean? Basically, it would be a bug that would cause it to play sounds even though you had set the game to be muted. So basically, that was a nice, quick, hacky, but very, very clean, but sort of just a quick workaround to not have to change all that code. Because as you know, when you set time scale to 0, the time will never get to these points. The time is frozen at 0, basically, right? Because we do it at the start of the layout.
Mm-hmm.
And then,
it is interesting how we've run into that sort of stuff many times before, where something isn't quite finished loading or something, yet you can execute code before that. So that is something I think to keep in mind across the board. You'll bump into those things from time to time using Construct, Yeah,
it's a super specific, very web-based data loading and sort of data streaming mechanism. You tell it to load something, it doesn't just pause the game for a second or two while it loads. It still keeps cycling through the code, even though you've initiated a load. And then you've got to do this thing to say, okay, do I have the data yet? Which it's going to check every loop of the code until it has that data. So in the meantime, it'll just keep going with everything else. And that would have caused a problem potentially if for some reason the data took a long time to load. Like I said, you might get the audio to start playing when it's supposed to be muted in this case. But as you can see, once we set up everything, now we know we've loaded in the sound settings and we've set all the volume levels and whether or not things are muted appropriately. Then we go set time scale to 1. Mm-hmm. So now it's safe. Now we let the clock continue, so to speak. And now it'll play the sounds at the appropriate volume. So that's what all this does. And so here's, you could see, this is the muting. So what we do is first we set the volume levels to the actual volume levels that you can set with the slider. But we do a secondary check after that that says, yes, but that might be how the volume slider is set, but that might not be the actual volume because they may have muted that at some point.
Right,
So we have to check, is it muted? So we have dictionary values, master muted, music muted, and sounds muted. And we set it, and I had to do some experimentation with this, but I discovered, and we'll get into this really with the sliders, and this might be out of ignorance with how to handle sound, but I wish it was a nice simple, you could set the sound volume of anything from 0, which would be completely silent, to 100%, which would be the natural full volume of that sound sample. Mm-hmm. But Construct does this much more weird thing to a non-sound person where it's all in decibels. And I literally had to experiment to find out, well, what is dead silence for like if you bring the slider all the way down to 0, I want it to be dead silent. And I had to crank my volume all the way up and experiment and make a little tiny program that allows me to adjust the volume in decibels up and down until no matter how loud I cranked my sound, no sound came out, even though it was playing sound samples. And I discovered that that was at least a nice even negative 50 decibels. Mm-hmm. And then the interesting thing is 0 decibels, you would think, oh, that clearly means no sound. But no, 0 decibels means the default volume of that sound sample. Right. So that's another conversion I had to do in the slider, which you'll see soon. Not only did we want a nice logical 0 to 100 in the slider, because that's way more intuitive to a human being. 0 is silent, 100 is 100%. So not only did we want that, but so we're converting 50 to 100. So we have to take the 100 value and divide it by 2 or vice versa to synchronize those values between the slider and the actual decibel-based sound settings. But the other issue could have been, luckily we avoided it in this case, we got really lucky. Sometimes if you're making a slider, you don't have the luxury of that slider happening to be exactly 100 pixels wide. But in your original design, we got really lucky. It was already 96 pixels, it turned out.
Yeah.
I just added 4 more pixels to the right-hand side, which already there was plenty of room on that side. So it worked out perfectly. And that eliminates a whole other bunch of fairly complicated math where you're now also doing a ratio of, okay, where is that slider knob based on the whole width of the slider, and okay, that's whatever percent, so that's how you convert that to get back to your base 100. But then again, we don't want 100, we want it based on 50, but that's not even enough yet because it's negative 50 to 0. So that made things a bit more complicated, as you can tell. Alright, so let's get into the actual event sheet for this layout, and ahead of time I commented everything, which should allow us to get through pretty painlessly, so we'll see what happens here. So this first event, react to downward press if the current menu position is up at the tabs. So what that means is to go back here really quickly to settings. These are the tabs. And this is a value of -1. So you can see here which is -1. This is also the same family as these buttons. It's just a more sophisticated version because it has different animations, one for each tab. And you're going to see soon that this pointer gets moved to image point 1. So like, let's say this is which of 99. So when you scroll down here and then you press down one more time, the which thing is selected, which button is selected, will go from, this is -1, this is 0, 1, 2, and then it hops all the way to 99. I did that because I wanted to be able to have the other menu buttons. Potentially there will be many more or fewer buttons. So I knew 99 would be safe. We're definitely not going to have that many other buttons. So from whatever is the bottommost button in any of these tabs, when you press down, it's going to go to 99, and that'll always be the done one. And then this is 100. So, but anyway, the point is, there's an event that will set this to the image point 1, and you'll see in here that it's got an animation for showing each tab being selected, and I forgot, there it is. So you could see I move that over so that it's a nice place for the pointer to start if that tab is selected.
Right.
All right. Yep.
And
good.
I also just mentioned on the side, for those who didn't see us go over this originally, the idea being, obviously it has to work with a controller as the game is best played with a gamepad, but also designed in such a way that it could work with any input, touch or mouse or otherwise.
Right.
So that's kind of why it's like this and not what you would see in a typical retro games options screen, which is just kind of like a bunch of text thrown on a black screen or a background, because that wouldn't be sufficient for something like a touch, or the spacing and all that is very important. I wanted to reiterate that just in case people were wondering why it was laid out this way, with the tabs and everything. So.
Yep, and come to think of it, that's a great point. I did not yet actually add the touch way to navigate through these in particular, these different selections. So I'll do that at another time and add that into another video in the future. But right now you can navigate there with the keyboard or the control pad. The other thing, visually, Corey did a great job designing this whole settings system. And because we're going to be making a lot of retro games based on the graphical limitations of several systems, including 8-bit systems, he designed something that was very, very pretty, very easy to read, and would actually be able to reproduce very well across the board from Sega Master System, like 8-bit systems and 16-bit systems. So, and we're going to basically use the same menu system in all of our retro games. So you're going to have that familiarity. When you pick up and play one of our games that we make using the same system, the player will always know exactly how to set the settings they want. But anyway, so let's get into the actual events. All right. When you press down, and you'll see which is -1, which means it's up at the tabs, and you press down, which is this, the value up down is greater than 0, which means they've pressed down. That value weight, which people that have watched these videos before, you know what that means. It defaults to 0, but when you do something, we set it to 5, and then there's another event later on in here that very quickly keeps subtracting 1 from it if it's greater than 0. And that's just so that you might want it so if the player holds up or down, it'll go through the menu options, but not instantaneously, like teleporting. Like it'll be like beep, 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 through the different options. So that's what that is for. And we do play a beep, speaking of beep, 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 beep. So, and you can see here we have that tag sounds. So if you muted it or if you put it low or high, that's going to be reflected in the beep sound in the menu screen itself. And then because it was -0 and we press down, we set which to 0. Now we're out of the tabs and we're into the actual menu options. And then we call a function called update which. So we just set a value called which to 1. So I made a function called update which that I can call every time. That's just going to do the necessary things to, in this case, it's just moving that little hand pointer, and it's resetting that little sine wave movement of the hand pointer back to 0, so that the hand doesn't start to get misaligned, because we're teleporting it, but it also has a built-in sine wave movement. So whenever we teleport it to a new place, we want to reset its position within that sound wave to its starting point.
Yeah.
All right, so that's what that does. And then react to down press if the position is not in the tabs. So now we have if which is not equal to -0. So now we know it's some other number. It means it's down in the actual one of the buttons present on that screen that that tab has displayed, basically. And then we have, and then we're doing this other check. Is the hand pointer overlapping a particular menu button? And we're doing this to retrieve a value from the current menu button. So if you can imagine, this is a little convoluted to explain. But so let's say I had pressed down once when it was here, so which was -1. And I pressed down, so now which is 0, and this little hand is overlapping that invisible button.
Right.
So because it's overlapping that, I can retrieve values in this particular button. And in any given settings screen that you open with the different tabs, it's going to be a totally different layout. So maybe you don't always press down to get from one button to another. Maybe you press down to get down here, but then you have to press right to get to a button over here.
Right, yeah.
So I needed to make a system that would be able to handle all the different screens. So what I did was each button that you're currently on, it has value. So you could see there's a which for the button, which always corresponds to the which up here, which keeps track of which menu option is selected. So when you press down, it sets that which value, which keeps track of which menu option is selected. And that corresponds to this particular button, and this hand is definitely always overlapping whatever button you've just navigated to. So we can retrieve those values in this button, which is up is -1. So now we know if they're on this menu option and they press up, the value for which should be set to -1. So it'll go back into the tabs, right?
Right.
And then you'll see for this invisible button, if you press up, it goes to 0, which is here. But if you press down from here, it goes to 1. And -99 is like a null value. That means don't go anywhere, that doesn't exist. There's no left or right for this particular button.
Mm-hmm.
But then you'll see once you're down here on this button, now there is a left or a right, and I made it so it'll wrap around. So if you're here, you can press left or right, and it'll go here, and same thing for here. So its which is 100, its up is 2, which will bring you back here. Its down is -1, I think, which will bring you back to the tabs, and its left or right is 99, which will bring you back here. So that's the tricky code that is allowing us to have it so that we can have this kind of universal event that if the weight is 0 and the player is holding down and it's not in the tabs, then we check what button is the hand pointer currently overlapping. And because of that, we can retrieve the value from this particular thing. And here you can see we can check so long as the down value is something other than -99. That means it's a valid down value, which means you should be able to go down to some option button by pressing down.
Right.
And then so now we set which to whatever the menu buttons down, right? So whatever value is on that button the hand is overlapping, you set which to there, and then you can see we call that update which is going to teleport that hand there and reset its sign movement. So now we've gone to the next menu button selection in that particular menu. And again, we play a beep sound, and we set weight to 5, and that just makes sure you can either tap it to navigate or you can hold it. But if you hold it for too long, it won't just start randomly teleporting to different menu options because the code is looping so fast. So then, same exact thing, but for up being pressed. Same exact logic. You could see now we're checking for that value called up in the current button, and we're just setting the value there, and we're updating. Same exact thing. And then same exact thing for pressing left and right. This in particular is for right. And that is, so up, down is both for up or down. It's number less than 0 for holding left or pressing left, a number greater than 0 for right, and it's the same thing with up and down. And then, so you can see the logic is the same, except, oh yeah, this is specifically for when it's up in the tabs, sorry. So it is the same logic, but this is when you're up in the tabs, and this is specifically to navigate the tabs. So you can see we're affecting a different value in that top sprite that shows the different tabs, and it's called which tab. And which tab can go from 0 to 3. So you can see here we add 1 to it if a player presses to the right, but then we have to do a check. We want to, if he's on the third one, if the player presses to the right and it's already on 3, it's going to go to 4, but 4 is an invalid value. So we loop it around to 0. So again, you can loop. You can go from the first tab 0. There's got to be an event somewhere that if it's on 0, here it is here. Or if it's less than 0, because 0 is valid, it'll loop around the 3.
Right.
Otherwise, it's the same stuff. Oh yeah, and in this case, because it's the tabs, we have to change the tabs animation to make it look like that particular tab is selected. And that's what this does. And you could see for the animation name, I think I discovered you can't name an animation just like 0, 1, 2, 3, 4. So I had to give it a prefix of I just used the capital letter A and then a number 0, 1, 2, 3, 4.
Mm-hmm.
So then I could use an equation that just says set the animation to A and then a string, which tab, which is a value from 0 to 3.
Mm-hmm.
So that's what that's doing there. It's just changing. Oh, yeah, and then we have the same exact system for the menu screen background, which changes that whole background area of the tab to be properly drawn and arranged for that particular menu.
Right.
And then, so here, I actually could have just used that function call which. Oh, I see. It's because it's specific to the top sprite instead of the other regular menu buttons. So maybe I did not make this one of the regular buttons because its behavior is so special, so that explains it. But it's the same idea. Instead of going to the regular buttons, it's going to the thing with the tabs. All right, so as I was saying, this is the same exact thing, but for when you press to the left, and we loop it around if you go below 0, because 0 is the leftmost tab, so we loop around to the rightmost tab, which is 3. The logic is all the same. Here's that event that just quickly brings that weight value back to 0. And then this here is another thing that this event basically just makes it so when the player did go from any button back up to the tabs, which would mean which is suddenly -1, which is why this is trigger once, which is -1. So this means as soon as this becomes true, it's going to do these actions. And we just move that pointer to the image point 1 of that current playing animation of the top's sprite, and we reset its sine wave movement. And then react to right press if the current menu position has a valid right direction. So this is when it's not in the tabs, so you can see which is not -1. So we're in among the actual menu options, and the player has pressed to the right. Then we're looping through each of the menu buttons. Which of the menu button is equal to the tops which? So that means the tops is the sprite that has the value which in it that keeps track of what menu option is currently selected. And then there's the which in the actual particular menu button. And this is making sure it has the match. So is this the currently selected menu button? And I could be doing, I'm surprised I'm not here. I think I did the code at 2 different times. But that's the same exact thing I was doing here with is this hand overlapping this? It's the same exact thing. So yeah, I'm not sure why I switched at one point. I think something wasn't working up there. And when I switched it to check for the hand overlap, suddenly it was working. But this code is all working fine too, which I'll demonstrate later. So I'm just looping through each of the buttons and saying, is this the currently selected button? And if so, and it has a valid right value. So remember, -99 means don't go to the right if someone presses right, because he's on a menu option that has no button to the right. And then, so we're setting the which again, that value is which current menu option should be navigated to, or, setting it to the current one, I should say. And then we play a sound, we call that function, which teleports the pointer. We set that value to 5. And then, stop loop. Yeah, so this is much more complicated than it probably needs to be. I'll probably switch this over to using the hand overlapping thing. But it's doing the same exact thing logistically. It's just going about it in another way. So, so that's doing the same thing. And we're just going to be doing the same exact thing for left and up and down. I think we already did. And then,
I think you'll have to change your commenting. Can you change the color of the commenting, or is it always yellow?
That's a great question. I never bothered.
Because with it being a highlight? Okay. Yeah. I was about to say you can change one of those to nuclear green, and you'll be able to see it a little better.
Yeah, there you go. Right. There is a way, too, that you can mark parts of your code to find it much more easily if you have to leave it and you want to come right back to it. Yeah. But that's too advanced for me. I never bothered learning that super useful feature, so I'll have to make sure I do that sometime soon. But anyway, so that's what that stuff does. Here's the actual function. Like I said, it just teleports the pointer to the right button and resets the sine wave. And then this initiates the fade out to go to the splash screen if the player presses the button when they're on the done menu option. So we know the done menu option has a value of 99. So if which is 99, wait is 0, fade is 0, that's another value in this fade out object that people that watch the much older videos in this series will know about. And then B1 is whether or not the button 1 is being pressed. That could be on a controller or keyboard or touchscreen. Then we set fade to 1 on this, which basically tells it that it should start fading out now. Or in this case, it's fading in. You've got a black overlay over the whole screen, and it needs to fade in to make it look like the screen is fading out, fading to black.
Right.
But anyway. So, and then we have a value in that fade out sprite called where to. And that's a text variable, and we can set that to whatever we need. So there's another event sheet called fade out events, I think. And it basically, when this sprite is done fading in, becoming completely opaque, which makes it look like the screen faded out, then you go to whatever layout is in that value called where. So you could see our layout for the splash screen is called splash. And that's what we set this value to. And we have a sound effect called selected, like a nice affirmative beep sound when you select a menu option. And it plays that sound, and you can see again it has that tag sounds. So if sounds are muted, you won't hear it. And then we do some quick checks here. Which tabs is not equal to 0? The slider knob. So which tab, again, is like which actual menu you have selected and which tab you had selected. And 0 is for the sounds, okay? Like setting the different sounds. So obviously these slider knobs should not be visible unless you have tab 0 selected. So that's all these do, is at any point if you're off of tab 0, hide these slider knobs. And if you're on tab 0, the slider knobs should be visible. So now we just have a group that I made called sound settings. So I'll just have a group like this for each of the different tabs menu options. And then you can see here on start of layout, all we're doing is playing one of the songs. This is currently actually at start of layout. We're setting the actual volume levels based on the data that we put into the global variables from that stored object.
Right. So, that way, if you've set it before and changed, it'll be where it was before.
Yeah.
Right?
And like I said, like I might readdress some of the stuff after I make it so you can actually save. Right now it doesn't. It's just always loading that one thing I made. And then you can change it once it's all loaded in the global values and in the dictionary object, but it's not saving back out to that text file.
Right.
And once it does, we'll have to decide, we'll probably have like default settings stored in a special place in that text file that you can't change. Or maybe we'll give them an option to save as default to override the original default settings. Who knows? But for now, that's something for another day.
Right.
But anyway, and you can see here, we're saving those values from 0 to 100 because that is more intuitive and because that's what the slider has to represent. But now we have to do this conversion. I had to figure out this math, this little equation. So master volume, which will be from 0 to 100, divided by 2 because we want it to be based on 50, not based on 100. But it's trickier than that because it needs to go from negative 50 to 0, not from 0 to 50. Right. So that's why after I do this equation to divide it by 2, I also subtract 50. So if it was a full value of 50, now it's 0 where it belongs, which is full volume. And if it was 0 in the settings and on the slider, then it should be negative 50. So this does that, right? This equation converts the 100, positive 100 based slider and data values to the negative 50 to 0 decibels that the construct needs.
Yeah, right? It's better to imagine that volume as altered decibel as opposed to what it's playing at.
Yeah, exactly.
Because it's got its own default, sound, whatever level, based on how that was made. So that's kind of how I perceive it. And it is strange though dealing with those numbers. Starting at 0.
And then like having to do this extra math and like figuring things out and jumping through these hoops so that it's very intuitive for the user, but it's really obviously necessary. Here we are just taking each slider knob, which has its own which value, which is based on is it for the master volume, the sounds, or the music. And we are simply setting its X position, and this is where it was really handy. Oh yeah, there's a reason there's a +1 there, which I'll cover in a moment, but it made it really handy that the slider was actually 100 pixels. That made it way easier. There was one less equation to do to figure out that ratio difference so that we could place the slider exactly where it needs to be relative to that value 100. So the equation is the slider box X, so that will be the leftmost pixel coordinate of the slider box. Right. And then I do +1, I'll explain in a minute, and then I do plus the master volume. So remember, that value is from 0 to 100. So if we set the slider all the way down to 0, then this would be set the slider tab or knob or whatever I called it. Yeah, slider knob. It would be right at the left edge of the slider box, which makes perfect sense. But the reason I'm also doing +1 is when I was testing it with the mouse, I noticed something a little annoying. So let me run it. All right, so yeah, we can hear the background music a tiny bit, but not much. Okay, you can see the sliders work well, but the problem is that if you're going quickly with the mouse, it could skip, like, because in like the next loop of the code, the mouse is now completely off of and not touching that invisible slider box that I use for the click or touch detection. Then this would stay at, like, even though you slid all the way over here, you want it to be 0, but it like stops at 2 or 1, right? Like, yeah. But now it's, so there, I just did it because I moved the mouse super fast. Like, you don't do that with your finger, but with the mouse you could really like do it. And I just made it so it was way less likely right now. So I can adjust the code later to make it so so it's downright impossible, so that even if you go off of the thing, if you had been sliding on this and you go further to the left of it, I'll make it so that it'll go to 0. But anyway, this was good enough for now, and I think it's only an issue with people doing really fast mouse movements. But then I did the same thing. So I'll just do it to master volume since that won't blast our ears. But so I did the same thing, but I added like 3 pixels over here to make it even less likely you won't be able to max out to 100 easily. So you can see that works really well. I'm going pretty fast and it's still allowing me to reach 100. So that's why I do +1, because this box, let me go to the actual layout. You can see how it's 1 pixel over to the left. So that's why I +1 for the position of this, to compensate for the fact that this is actually like 104 pixels wide. Right, yeah. And so you don't want to put it at its leftmost position. You want to do leftmost position +1 because it's 1 pixel over to the left. And then there's 3 pixels here, so I just cap it. When you're sliding it over this way, you'll see that I just do a clamp so that the highest value can be 100, and that's the farthest over it can go. You'll see that in a moment. So let's get back to these events. Yeah, we're setting the X position to slider X plus. This isn't while you're sliding, this is just at the beginning of the layout, making sure that all of these slider knobs are in their proper place based on that saved data for where you had set it and saved it before. Yeah. And then we're doing the same thing at the beginning of the layout with the actual volume settings. And then here, the same thing as with that other screen. After we set the actual volume based on the actual slider settings, we have to do a double check and go, yeah, but is it muted? And if it is muted, we set the actual volume settings down to -500, which is absolute guaranteed to be complete silence no matter what. So like I'm very confident with my -50 is dead silent, but I just wanted to be super, super safe that it will be impossible for someone to mute and for it to not be dead silent. So I did -500.
I'm wondering if, so in this instance, if it was muted, you could still move that slider around even though it's not going to do anything.
No, actually. That's a great question. I had it that way initially. I wasn't checking whether or not the mute box was on. Oops, yeah, that's right. I can't, because it loads at the load up screen, the data. If I just try to go to debug, if I just run this layout directly, nothing will work because it didn't load the data from that file. So I have to,
Right.
if I'm testing the settings screen, I have to start at the actual loading screen, let it load the file, and then go into options from the splash screen. Obviously, if that becomes too time consuming as I work on these other tabs, I can just copy that code from the loading screen in here so that I could go directly, and then I would just delete it out of the events for this screen before we publish the game.
Right.
But so you can see this is muted, and I cannot touch and change the slider, and I cannot, if I navigate down here left and right on my controller or keyboard, will not adjust it either. You have to unmute it, and then
Yeah, I may end up doing like when you do mute it, like
Yep.
it just kind of like grays
Grays
that
it
out
out.
or something, so
Exactly.
it's just frozen, sort of.
Right.
Yeah. I like that though. You really did think of everything for this.
Well-
You went all out with it.
Thanks. Yeah, I mean, once I got it working, it was time. Like I was testing it anyway, so I thought, oh yeah, that's counterintuitive that it's muted, but you can adjust it, and you're kind of expecting the other option would be to make it automatically unmute, which I did not like because it's a separate setting, which is very easy to unmute. So it just made the most sense. But I agree with making it grayed out so it's obvious. But yeah, it's the most intuitive this way. Let's get back to the events. All right, so yeah, so we're setting the master volumes down to -500. There's actually a construct action to mute specific tagged sounds or the master volume, but I tested that way and it wasn't working the way I expected, and I can't remember what it was. Maybe it muted, but then if you triggered a new sound, that new sound wasn't muted or something annoying. So, but then because adjusting the volumes I already knew was working perfectly, I just said, screw it, I'll just adjust the volumes down to such a low number that it's guaranteed absolute silence.
Right.
Oh yeah, and then because we have to do that conversion to get to the decibel formula, and because I know we're going to have to do that math frequently, because you'll see when we're triggering a sound, oh, I'm on the wrong events, that's why, hold on a second, settings. There we go. All right, so you could see here when we trigger a sound. Okay, so here where we're playing a sound, you see how we're playing it at volume sounds dB? So because you can set your specific volume up here, that was causing an issue where you would change your sound settings, but any new sound that started, it would start playing in its default sound because it used to be set to like a hard value of 0, which means it's full volume. So I'm doing that math there. All right, so I found where I had been before I sort of accidentally digressed back into that other event screen. So here we are. We updated the actual volume settings, and then if the mute had been set or not, we're updating the animation of that particular mute button. And of course, we're actually muting the volume. And we're doing that for each of the different types of mute buttons based on their which value. And then if selected tab is the sound setting stuff in the master volume section is selected. So remember which tab is 0 means that we're on the sound settings screen. And then which is 0 means 0 in this case means that's the button 0 is the pointer is now showing you you're on the row to affect master volume. So you can see like that's a big main event, so to speak. And then all of these are sub-events. So this has to be true for all of this stuff to happen, right? Or first you check if this is true, and then if that's true, you check this other stuff to see if that's true also. And then if so, then you do this stuff. That's how that works. So again, weight is 0, left, right input is -1, which means someone tapped left, right? And then we're checking is muted 0, right? So this is important. It's not muted. So
Right.
again, that right there, that's what makes it so that you cannot adjust volume if it's muted. And then so if that's the case, we update the actual master volume setting. This is the global value. This is the actual construct audio setting for master volume. We set weight to 5. And then we also have to find the slider knob that is the slider knob for master volume. And we do this little formula. We set its X position. Same exact formula I showed before. It's the X position of the slider box plus 1 plus the master volume value. So that will update the position of the slider to match what you just adjusted it to with the controller tapping to the left. And then the same thing, now we have the number too, that sprite font.
Yeah.
So there's a sprite font in each row, one for master, one for sounds, one for music, and you can see we have a same thing. We have a variable in it called which keeps track of which one it is, and we just set its text to be that particular newly altered value of master volume, which is a global value. And we're just converting that numerical value to a string so we can display it with the bitmap font. And then the same exact thing for if you press to the right, but now we're adding 1 to master volume instead of subtracting 1. Everything else is identical. And then down here, if button 1 is pressed, and remember this is if you're on specifically the master sound row, and you press button 1, we check, is it currently muted? And if so, set the value to no, you're not muted anymore. Update the volume setting to no longer be muted and to match where the slider is. And we set weight to 5, and we find that particular muted button, and we update its animation so that it's showing the animation which shows that it is not muted, which is the default animation. And then this is if you press the button and weight is 0, but it was not muted, then you set it to yes, indeed, be muted. You update its animation to be muted. You set master volume to -500. You set weight to 5. That's what that does. And then if the player is in the sound section and the master volume selected, so this is the same exact logic as above, but now you'll see it is every so many fractions of a second instead of just a one-shot deal, right? And you can see that's why we got rid of weight equals 0. Because now you could just hold it down, left or right. And the reason I did left-right input is less than -20. We need a little bit of a gap. So if I just said if it's less than 0, sometimes if you just tapped left for a split second, the little slider would go over more than 1 notch.
Right.
Because the event above for when you're pressing left would take effect, and then this one would take effect too, because both are true. But now you have to hold left for a fraction of a second, a good long fraction of a second, so it won't accidentally trigger. It'll never accidentally think you're holding down to the left, even though you only tapped it. Because we need that precision. We need someone to be able to tap and go 1 notch at a time.
Right.
And again, we're making sure it's not muted. Otherwise, you should not be able to do this. And otherwise, the logic is the same. It's just, it's not doing the is weight 0, set weight to 5, because you can do it holding it down indefinitely, so many fractions of a second, but you have to have been holding left for a while, and then it's going to be the same exact thing for holding to the right.
Yeah.
And then this is the same exact logic now, but it's just for when you're on the second row, which you can see now, which is 1 instead of 0. So now we're on the sound row. It's master sound, and then sound effects, and then music. Those are the rows.
Right.
But the logic is exactly the same as I covered above. And then we do the exact same thing for the music volume sliders. And the first few events are for if you tap, and then after that, it's if you hold. And then what is this? Okay, yeah, so this is the event that I had started talking about before and then got lost. So what we're doing is if the sound is not muted for sound effects, then we set a global variable I had set called soundsdb to sound volume, which is the global value that keeps track of, like when you change the sound effect slider, divided by 2 because it's based on 100, and then -50. So again, the reason I did the math one time here in the event loop is because otherwise we'd have to do that math in every last action where we trigger playing a sound, where we can set the volume. We'd have to put that whole equation, and that would mean every time it's playing a sound, it has to do that math again.
Right.
And that we have to copy and paste. And then imagine if I decide for some reason to debug or to change something and I need to change that formula. Imagine if I had pasted that formula in every event in the entire game that plays a sound effect. I'd have to hunt down every last action that triggers a sound and paste in the new formula. So I just do it once here, and then I just, instead of putting that formula, I just put the global value that already had that formula done to it. And then this is interesting. Let me run it again. One moment, please. Mm-hmm. Your call is important to us. Please continue to hold. All right.
Call will be answered in 30 minutes.
Yeah, exactly. As soon as the next operator is done playing Candy Crush.
Right.
All right. So, I'll put master volume all the way up so you can hear it. I'll unmute the sounds, and I'll make it louder, and you'll hear. Oh, and I'll make the music quieter so I don't have to make these super loud. But I realized that if the player is trying to adjust sound effects volume, they need to hear the sound effects relative to the volume of everything else. Right. So I made it so that when you're on that row, every second it's going to play one of 4 different sound effects from the game. A very quiet one, 2 relatively medium ones, and then a loud one. Mm-hmm. And that way, when you're adjusting your sound volumes, you can actually hear how that's going to be in-game relative to the music. So you could adjust them all perfectly relative to each other. Mm-hmm. And then we'll just mute both. And now, obviously, even though master volume is 100%, because both things are muted, you can't hear a damn thing. And we can unmute. So you can see that's all working very nicely. So anyway, that's what these events are for that we're about to cover. So you can see it says play sounds. I just put it in a group for the sake of organization. And it is. Which tab is 0? That just means we're on the sounds menu screen. Which is 1, which is the second row, which is sound effects. Every 1 second, we're going to add 1 to which sounds. Which sounds is another global value I created that starts at 0. If which sounds equals 4, because we're adding to it, we want it to go from 0 to 3. So if it's 4, we need to make it loop around to 0.
Right.
And then if it's 0, you play this sound effect. If it's 1, you play this sound effect. And you can see they all have the tag sounds, and they all, for their volume settings, call that global value that already did the formula. It already did the math to figure out the actual decibel setting based on the sound slider setting. All right? Cool. That all makes sense? So that's all it took to make it. When you're on that row, it just goes through 4 different sounds so that you can very accurately set your sound effects volume. And then this is the hand-coded. I should mention, Construct 3 has a very nice, very functional slider object. You could just drag it in, you could set it, you could set its range. It does all that math to convert if your slider can't coincidentally be a perfect 100 pixels, which will usually be the case. Then it automatically adjusts that. You tell it what its maximum and minimum volume are. I originally coded this using those built-in objects, and I was like, oh, this is awesome. This saves me a bunch of time. And then I ran into several limitations that just ruined it. One, if you made the built-in slider that it had, the slider object, if you made it visible, it no longer worked at all. So that ruined it right there. The other problem is when you made it visible, it forced itself on top of everything else. So at first I thought, oh, that sucks. It has to be visible. So I thought, oh, okay, I'll make it visible, but I'll hide it under a sprite. Perfect crime. Nope, right. It'll always go, even if it's on another layer. Like, even if you put another layer on top in a sprite, it's going to just go all the way to the top of everything. So that was a game breaker right there. And the other thing that was terrible, the down and up arrow keys should let you navigate down and up in the rows, in the menu buttons. Mm-hmm. But if I had touched the built-in slider object, suddenly the up or down arrow keys on the keyboard adjusted the slider up and down. It was hijacking the button input, so it no longer worked to navigate away from that whole row. So it was catastrophic, and then I just had to code everything by hand anyway for the sliders. But luckily I had experience with hand programming sliders before, and it's not that hard. So here's what I did. Let me zoom out. I just created a sprite that was at first perfectly 100 pixels wide, but then I added a little padding after, which really didn't complicate things too much. And that's all I needed to do there. And then I think I gave it, of course, a which variable so that we knew if it was the one for the master volume, the sound effects, or the background music volume. And I think that was actually all we needed to do. So let's go into the actual events. And you'll see we have, if a slider bar is being touched, that's a main event, and then there's sub-events. So if that's true and this is true, it is the one for master volume. And important again, master muted is no, it is not muted, so you should be able to adjust it.
Right.
Then one we're setting, because you should be able to touch it and start sliding, even if the little hand pointer is not there. So I immediately have to update which to 0, just in case they weren't there already, and call that function that will teleport the hand pointer there. And then slider knob, I have to make sure that it is that right one. And so I just say, is it the slider knob that's overlapping that particular slider box? And then what I do is I set its X position to clamp. And the reason I use clamp is because I had to make the actual width of the slider box bigger than 100. To get rid of that issue where I could slide my finger too fast and it wouldn't go perfectly to 0 or 100. So that's why I'm clamping it to... So this got more complicated than I thought it would have to be, but it's because of the way retrieving the X coordinate of a on-screen touch works. So the value ended up being integer because this is a pixel art game, so we want everything to go to a pixel perfect location. So integer... viewport left, which is, it doesn't matter how big your layout is, whatever the coordinate is of the leftmost pixel of the visible screen, of layer 0, that's what the parenthesis 0 is, plus the X coordinate of the touch, and 0 just means it's the master touch, it's the touch that just happened. Slider box, bounding box left, which is the leftmost edge of the actual slider box you're touching. But remember, +1, because I made it bigger, so we have to nudge it over a pixel. And then slider bounding box right -3. So that's the clamp, that's for the clamp. Clamping is to make sure, even though I can touch and slide it beyond the value 100, the maximum position that the slider can go is to 100 pixels over from the leftmost edge of the box. +1, sorry that's complicated, but if you pay careful attention, that all makes sense. We set the global value, master volume, to integer again because we want it to be a nice clean number between 0 and 100. Slider knob X, so now that we properly updated its position, now we can use its actual X position minus the actual slider box's position. So that'll always give us a nice value from 0 to 100, so long as we compensate for the fact that it's over 1 pixel too many, so that's why it's -1. And then we set the master volume to that global value we just set, but we do that formula to get it to a decibel system based on -50 to 0. And then we have to find the bitmap font that is this particular thing, which is in this case master volume, and we set its text to the string version of the global value we just set. And then it's going to be the same exact logic for the sounds slider bar and slider knob, and then the music. So that's it for those. And then the last thing we needed to do was make it so that you could just touch those mute buttons. Like you saw above, we already made it so if you press the button, it'll toggle whichever row you're on, master, sounds, or music. You could just press the button to toggle mute it on and off. We needed it so you could just instantaneously touch and mute that particular sound. So that's what this does. If you touch any mute button, we find out which one it is. So yeah, this is the master one. You've touched it. It is muted already. Weight is 0. And then you do all the stuff you need to do. I'm not going to... You've already seen all this stuff, right? When you mute it, you got to do these things. It's the same exact things you had to do if you press the button to toggle it. So we're just muting it or unmuting it based on you touching it. And that's it. It's the same exact thing for sounds and music. Either toggling it on or off. That's what those do. And that is it. Yeah, it's all working great. The only thing it does not do is save it to the actual file, which the reason I'm going to do that next time is the code I'm going to do before our next video is actually make this tab here work, which I can't show you yet because the graphics is not yet imported into Construct. It's going to allow you to save, as I said, in different slots. So I'm going to do all that code to make the sound settings and eventually the custom input and the custom screen settings. All of that you'll be able to save in different slots. So that's what will be in the next video. And that is it for this video, unless you had any further thoughts or questions or comments, Corey?
No, nothing other than just, I think you really went nuts with making all this work as perfectly, like better than even I thought it would be. Because originally I was thinking the sliders, like if you adjusted them with a gamepad or something.
Right.
Would go in maybe larger intervals or something, but you did it pixel perfect, and I think that's better. So it's more in depth, and also the looping of like when you're on a tab or a menu or something, and it loops around based on hitting the other direction. I think that's something I didn't think of either. So it seems like you really nailed all the different aspects of the usability.
Yeah, I mean, especially for an arcade style game that's fast action. If you need to go into a menu system to adjust something, you want to be in and out. You want a really fluid experience that you're over with quick and you're in the game. And like if you're going to program to make it work, once you get it working in the first place, using it and testing it and putting in the extra effort. Imagine you had to go all the way into game and start playing the game in order to know for sure if your sound effects and your music have a nice balance the way you want it.
Right.
So yeah, it was really important to put in that extra work and just figure out what needs to happen. And like that thing, the first time I programmed it, like I knew I wanted it, so if you held left or right, it would go quickly, so you wouldn't have to tap, 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 tap 100 times to go from 0 to 100. Like I knew that was the case, but at first when I programmed it, I just made it start to happen immediately. And then, of course, I had that bug where even though I had this code to make a pixel perfect, you tap it, it goes exactly 1 notch. Because I hadn't thought of it, before I put that less than -20 or greater than +20 for that value of left or right, it was just boom, like it made it virtually impossible to just make a nice, we'll say pixel perfect, but 1 integer perfect adjustment.
Right.
So then I realized, like luckily I had foresight in the way I set up the input events, so that if you're holding a keyboard key or touchscreen or control pad left or right, it's not just a value of, yes, you're holding left or right like binary. It keeps adding to that value as you hold the button down. So we can actually keep track of how long a button is held down. And that saved the day in this case. So there's this really nice, incredibly fast. It's just long enough so you'll never accidentally go 2 or 3 when you want to go 1. But it's super responsive. As soon as you start holding it, there's like a very tiny gap of time between when you start holding it and when it starts moving nice and quickly for you.
Yeah.
So that, that polish really just adds an immense amount of, just, you want it to be very pleasant to use, very responsive, very intuitive. So it's worth that extra effort. But thank you for the compliment and thanks for that extra point for the end of the video, Corey. So that will be it for this one. Thanks so much for watching. Thanks for your patience as there are these larger gaps these days in between videos. A part of it is because there's several things we're working on for this game behind the scenes that we can't announce yet. Including there's obviously we're still coding the level 1 boss fight and stuff like that, which we also can't show yet. So thanks everyone for your patience and thanks so much for watching.
If you enjoy our content and want to keep up to date on our games, please leave a like and subscribe. Also, if you want to support our projects, consider becoming a patron. The link's in the description, and we'll see you soon.